Hello dear student, I am Monu Islam. Today in this video we will discuss some important question of point-set topology. Okay, so there is something written and write after that. Okay, so R is the set of real number and Q is the set of rational number. Then 0 less than epsilon less than half. Okay, epsilon the top end of this. Then this first option supreme epsilon less than 1. This says okay. So see 0 less than epsilon less than half. It is imply f and also given epsilon is this 0,1 minus epsilon. Okay, so if you multiply minus 1, this gives this gives this. You can say 1 minus epsilon be this interval half comma half. 1 minus epsilon be lies between half and 1. Now, supreme epsilon. So epsilon is nothing but top interval 0,1 minus epsilon. Okay, so what is supreme? 1 minus epsilon. So supreme, this becomes supreme of 1 minus epsilon, where 0 less than epsilon and half. Now 0 less than epsilon and half, if you multiply minus 1, this gives add 1, this gives this result. Okay, so you can say supreme of 1 minus epsilon will be 1. So this becomes 1. So supreme epsilon this will be 1. Okay, so this is not 1 now. So this is incorrect. Now going to option 2 and 3. 0 less than epsilon 1 less than epsilon 2. Okay, 0 less than epsilon 1 less than epsilon 2 less than half. Okay, so if you multiply minus 1, this gives this result. Okay, then add 1, this and this gives this result. If you add 1 from both sides, then you get this result. Half less than 1 minus epsilon 2 less than epsilon 1 less than 1. Okay, so draw this picture. 0 less than 1 half less than 1 minus epsilon 2 less than epsilon 1 less than 1. Now a epsilon is this 0,1 minus epsilon. Okay, so what is a epsilon 1? 0,1 minus epsilon. Okay, what is a epsilon 2? 0,1 minus epsilon 2. So from here easily understand, you can easily understand that 0,1 minus epsilon, this is this open interval, and 0,1 minus epsilon 1, this is this open interval. So it is obvious na. From here you can see 1 minus epsilon 2, epsilon 2 is contained in the interval epsilon 1. Okay, this figure is clear. Okay, so now if you take supreme of the interval epsilon by 2, this is condition B. So this become what? Supreme of the interval nothing but 1 minus epsilon 2. Okay, so 1 minus epsilon 2 is lesser than 1 minus epsilon, lesser than 1 minus epsilon 1. So you can say this supreme of nothing but epsilon 1. Okay, so this is the option in B na. I think this is option in B. Supreme epsilon 2 will be less than supreme epsilon. So option 3. So this is right. Okay, now if you take infimum, see, if you take infimum of this set, this and this set, so what is the infimum? The 0 itself na. If infimum is 0, it is this epsilon 2 infimum is 0, epsilon 1 is infimum also 0. Okay, so this is option 3. And option 2, if you take infimum of epsilon 1, so this gives 0 itself, and it is never infimum epsilon 2. Okay, because infimum epsilon is also 0. So 0 less than 0, so it is if condition, so 2 is incorrect. Okay, so option 2 is incorrect. So you can say this is incorrect. Now supreme epsilon intersection Q and supreme epsilon intersection R minus Q. This says this. Okay, so see supreme fourth option epsilon intersection Q. Okay, and it's saying supreme of this and supreme of epsilon intersection R minus Q means epsilon. So epsilon is nothing but the interval 0,1 minus epsilon na, this interval. So if you take it supreme, if you take epsilon is this interval 0,1 minus epsilon. Okay, so if you take it rational, epsilon is rational, so this gives 1 minus epsilon rational. So what will be the supreme of this interval? What is supreme of this set? Okay, because it is nothing but if you have to take a member of the epsilon that are rational. Okay, but supreme is the 1 minus epsilon itself na. So it is supreme is 1 minus epsilon itself. Now this epsilon intersection R minus Q means you have to take a member that are irrational in this interval, member that are irrational. Okay, so its supreme is again 1 minus epsilon. Okay, because no member is greater than 1 epsilon na. So this two are equal. So both is that. So in this question card is 3 and 4. So card is So this is a nice question. Okay, so this is a partial question, and this question asked in December 2017. Okay, now we are going to discuss one more question. One by plus one by lead point. The question in June 2013. Okay, this question solution I written because in previous I have tried to make a video, and the time my laptop is going to problem, so I can't upload the video, and the solution is written also. Okay, so see this 1 plus 1 when is just a number. This lead point. Okay, all the differential lead point. What is the lead point? It deleted number should contain a member of the set. Okay, so it is deleted number is in this alpha epsilon, in this n is non-empty. Okay, deleted number should be contained as member of the set. So it is the lead point. So in this you can easily find the lead point of the set. Okay, so here it find see s1 greater 0, then there is m can find 0 less than 1 less than s1 2. Similarly 0 less than 1 less than s1. From thus I can say from argument property. Okay, argument property itself. You can say this from argument property because say I have written here below. We all know argument property. If x is positive number, y is positive number, there is a natural number n such that n greater than x. This argument property. X is positive number, y is positive number, then there is n we get such that n greater than x. Because you can say every real number is can bound by a natural number. Okay, this is the result. So if you take y is 1 and x is 1 by epsilon, 2 by epsilon, x is 1, y is 1 and 2 1 is positive now. If you take y is 1, then 1 is positive. If you say x is 2 by epsilon, it is also positive. So if you apply here, you can apply argument property. So in dot 1 give 2 epsilon. Now it take this equal 0 less than 1 less than epsilon 2. Okay, so you can choose, if you choose n equal to m, so this what gives, so this gives this unit, you can say 0 less than 1 by less than epsilon 2 na. So I have written that I have taken these two inequality. Now if you add this two inequality here, then you get this. Okay, now 0 less than 0 greater than minus epsilon. So now you can write 1 by m plus 1 by n belongs to this interval. Now this number is never 0 because m is less than number na. So this number is never 0. So you can say this number belongs to actually the deleted number in the 0, epsilon. Okay, this number is also set. So you can say 1 by m plus 1 by n is nothing but belongs to this n dash 0, epsilon because this is never 0. So it belongs to this set, and also set was equal to intersection. So intersection is not enough. So n dash alpha epsilon, this is never difference of the lead point. If n dash alpha comma epsilon intersection is non-empty, okay, then you can say alpha is lead point. So from here you can say 0 is lead point na. So 0 is lead point. Similarly you can prove that 1 by m or m is number is lead point. Okay, see it is also written. This epsilon greater 0 then minus epsilon less than 0. Similarly, if you apply argument properties, then you got 0 less than 1 minus epsilon. Okay, that I have to tell you. See, 0 greater than minus epsilon. So if you add both sides, then you got 1 by m. So this gives 1 by minus epsilon less than 1 by plus epsilon. 1 by m plus 1 by n less than 1 by plus epsilon. Okay, so this, and you can say from here that this number belongs to the upper interval 1 by minus epsilon 1 by epsilon. Now this number is never equal to 1 by m. Okay, 1 by m plus 1 by n. This number never equal to 1 by m. Okay, because this is non-zero na. So you can say this belongs to the deleted neighborhood n dash 1 by m constant. This is neighborhood centered on m. Okay, radius epsilon. So you can say this belongs to n dash 1 by m constant. But this neighborhood of the set also na. So it n dash 1 by m constant is non-empty. Okay. This member is a member of the deleted neighborhood. This is also a member of the set also. So this is going to intersection. Now intersection will be non-empty. So n dash 1 by m epsilon dash is non-empty. So you can say alpha is lead point na. If n dash alpha comma epsilon dash is non-empty, alpha is lead point. So 1 by m is lead point. Okay. So 1 by m is the m natural number is a lead point. So lead point of set will become 0 in 1 by n when n is natural number. Okay. So it's set is infinite lead point because if n is a natural number, so 1 by n is a natural number na, and this gives infinite natural number. Okay. Infinite meaning. So this set is lead point infinite. So in this question correct answer will be 4, I think. This question infinite will be in 4th option, so correct answer will be 4, infinite one. Okay, so we are going to one more question also. This question part C I told you. The question part B I told you. Now to discuss one more question. This question of argument and property. Okay, this question came I think December 2016. Okay, so it's saying a belongs to 0, 1 of interval, then this happened. Okay, so see if a belongs to 0, 1, this means 0 less than s less than 1 na. So This argument property says that not argument property. You have to apply density property bar. Okay, density property bar. What is density property bar? Is density property R is between any two real number. If you have two x and y be any two real number, then you can find a rational number. More one, not one. You get infinite rational number in between them. So there is a rational number such that x less than r less than y. You can also find a irrational number s such that x less than s less than y. Okay. And moreover, it is infinite. You can find infinite rational and infinite rational number between two real number. Okay. You have to apply this. So 0 less than 1 by s, 0 less than s. From here you can write there is a rational number n by n rational numbers such that 0 less than s less than this will happen na. So you can say s greater than 1 by n. So this is also known as that. Similarly, if you s less than 1, then you can find this s is a real number, 1 is a real number. So between there is a real number, there is also a rational number na. So this is the form you can say s less than 1 by n. There is a rational number. So I am making so if s greater than 1 by n also. So this is correct one. Now s belongs to 0 1, it doesn't imply s is rational. Okay, s may be irrational na. If I choose suppose s equal to 1 by root 2, okay, then this number belongs to 0, so get a 0 less than 1, so this number belongs to 0. But this number is rational, this is not rational, this is irrational. Okay, so you cannot write like this the form by n. So this is one is incorrect. If you write s equal to n plus n, this m is integer natural number, n is natural number, so s becomes rational number. But where is it is mentioned that s is rational number, s may be irrational also na, then it is not equal. Okay, so it is incorrect. So in this question, correct option will be 1, 2. Okay. So hope you understand this question. Now, see this question. This question asks in I think December 2013. Okay. D is a subset of real line. Consider every infinite set in D, which is a subsequence. Is converges to this is nothing but definition of compactness. Okay, this is definition of sequentially compact. You can say sequentially compact. Okay, we all know every sequentially compact matrix space is a compact. Okay, every sequentially compact matrix space will be compact. So we can say this is definition of compactness. So D is subset over, then this the expression this, then this is true if D what. Okay, so D should be compact. If it this body whole, then this sequence is compact, and every sequence matrix is compact. So D should be compact. So in R there is also more result. D is compact if it is close bounded in R. Okay, this compact will be close bounded in R, not in every matrix space. In R comma D, you can regional matrix space. Okay, so this compact, but compact means close bounded. Okay, this is not bounded na, so incorrect. This is not this is not close. -1, 1 this is not close na. 1 is not in the set, so you can say this in that. Now this 3, this is not close also, because this says D will be this -1 in 1 is open. Okay, 3 and 4. 3 is closed. Okay, and this is closed and this is open. So here 1 become lead point na. If you took a neighborhood of 1, since you can make like this 1 plus 1, take a neighborhood 1. Okay, so you can say 1 belongs to this neighborhood, 1 minus epsilon, 1 plus epsilon. Okay, now you can, if you exclude this member 1, also this set. Okay, so what this become? This become in this 1 comma epsilon. Now you would take the intersection in this 1 comma epsilon with D, then this is not na. Why not it? Because these member are common. These member are common. So not this 1 become a limit point. Okay, 1 become a limit point. Now 1 become a limit point, but 1 is not in the set. Okay, so 1 so if it is closed, then it is called a limit point na. But 1 is a limit point which is not in the set, so it is correct. It is correct because it is closed. You know, it is closed. It's closed. So in order to close it, it's closed. Okay, so it's closed and it's bounded also. Upper bound is 4, lower bound is 0. So it's bounded. So closed bounded but compact. So it is sequentially compact. So option 2 is correct. So in this question, correct option will be option 2. Okay. Now, So hopefully today I discuss one question from part B, this question from part B, and this question from part C. This is very important question. Okay, maybe in previous and in the next upcoming exam, one more question can be came of this type. This is very important question, and this is a conceptual question. Okay, you cannot solve this question with very much concept of concept topology. Okay, this very much concept needed. Okay, so after in next video we'll discuss the remaining question. Okay, and we'll close this chapter and we'll go to the chapter sequence. Okay, so don't worry, follow my channel, and you'll, if I get time I must type our video. Okay, so don't worry, follow my channel. Okay, so thank you so much.